Hi guys, David here with another science update. So today we're going to talk about the sounds of Mars, and this is enabled by the Mars Perseverance Rover, which unlike prior generations of Mars rovers actually has microphones on it. Now, microphones on a rover are useful for a couple of reasons. One is obvious, you can hear what Mars sounds like, but it's also useful in terms of just being a different form of scientific information that can be taken apart and looked through, and you can learn things from it. So, if you think about it, what an audio recording is doing is it's just picking up certain wavelengths of vibration. And that's what a camera is doing. A camera is picking up wavelengths of vibration, and different forms of analytical devices like spectroscopy are also just looking and interpreting different forms of vibrations. And so if you think about it, audio data is just like that. It can be taken apart and you can learn a lot from it beyond just what things sound like. That being said, there's also this other layer, which I'm excited about because I've actually not listened to these recordings before. I listened to like a brief snippet yesterday, but I realized I wanted to listen to the whole thing with you guys. At an emotional level, it's pretty wild to be able to hear what things sound like on a different planet. And so what we're going to do today is talk a little bit about this article from NASA and what they're hoping to learn from the audio recording devices that they put on the rover. And we'll also just listen to some of the sounds of Mars and talk about it. So they say they have 2 microphones aboard the 6-wheeled spacecraft, and this is adding a new dimension to the way scientists and engineers explore the red planet. Thanks to these 2 microphones, the mission has recorded nearly 5 hours of Martian wind gusts, rover wheels crunching over gravel, and motors whirring as the spacecraft moves its arm. It's like you're really standing there, said a planetary scientist who studies the data from the microphones. Martian sounds have strong bass vibrations, so when you put on headphones, you can really feel it. I think microphones will be an important asset to future Mars and solar system science. So that's interesting, this idea that Mars sounds would have a strong bass vibration. Okay, so here's why. Because the planet's atmosphere is much less dense than Earth's, scientists knew higher pitched sounds in particular would be hard to hear. So in other words, like the composition of the sound that you receive from a microphone in Mars' atmosphere is going to be different than the composition of the same sound that you would hear in Earth's atmosphere because of the density of the atmosphere. So it looks like if the high-pitched sound doesn't propagate very well through the Mars atmosphere, then when you hear something happen on Mars, you're going to pick up, as a proportion of the total sound, more of the bass notes. All right, well, let's listen to some of these sounds.
One of the microphones is mounted on the mast and moves around as we point the cameras. The other microphone is mounted to the rover body, and it stays fixed onto the port side of the rover.
The 2 microphones that we sent were commercial off-the-shelf items. So these are things that you could just buy on the internet, and we put these on our rover.
It gives us a new dimension for which we can explore Mars and learn about the Martian environment.
First, we can just learn about the atmosphere by understanding how sound propagates through it. But we can also listen to the sounds of rover analyses on rocks and learn about rock material properties from that. And finally, we can also listen to the sounds the rover makes to understand better the state of health of our instruments.
There's a difference between Mars and Earth sounds.
Yeah, that makes sense. They were talking about in the article, I didn't bring it up, but there's this, it's kind of like listening to your car, right? You can sometimes hear certain sounds and you go, that doesn't sound right. And I imagine if they have a good baseline for what the Perseverance rover sounds like when it's functioning well, then if something goes wrong later on, they'll probably be able to hear it. I mean, I imagine one thing could be, you might get sand in some of the gears of the Mars rover, and then you might be able to hear the sound of that sort of like grinding in the gears. That could be a good diagnostic. Okay, so the first thing they're going to do in the video is they're actually going to play a recording of sounds on Earth and then simulate what it would sound like on Mars. And so they did say that headphones are recommended for this. So let's go ahead and get them in.
There's a difference between Mars and Earth sounds. Sounds on Earth have very rich harmonics. You can hear multiple frequencies. It gives a really nice depth to the sound. On Mars, the atmosphere attenuates a lot of those higher frequencies, so you tend to hear the lower frequencies, and it's a much more isolated sound, a little more muted than the sounds we hear on Earth.
It's interesting, the sounds of the birds singing, when you listen to it on Mars, you don't have those high pitches, so it almost just sounds like, I don't know, like like white noise almost, you know, or like a wind tunnel.
We've put together a list of some of the sounds we've recorded on Mars to date. So let's take a listen.
This is the sound of wind on Mars. For the first time, we can hear the wind blowing across the surface of Mars to go along with all of the images that we've acquired of dust devils and dust storms over the many years of exploration on the surface.
Wow. So we're going to have to listen to that again, I think. But so that's the sound of wind on Mars. Wow. Okay. I'm reminded of a science fiction series I read, and I can't remember the author right now, but it's a series of books about terraforming Mars, which is to say taking Mars and making it habitable for human life by actually purposely doing things like releasing greenhouse gases to do global warming, and eventually sort of like building up an atmosphere that is more breathable for humans, and growing plants and trees and all that stuff, and eventually releasing animals and growing crops, and kind of making it like an Earth 2.0, or as close to it as it could be for something like Mars, which is just a fundamentally different planet. And what was interesting about it is that the first book in the series is called Red Mars, and then the second is Green Mars, and then the final one is called Blue Mars. And that sort of reflects the fact that the atmosphere, or that the whole biome of Mars is changing. Red Mars is the first. It's about the first human mission to Mars, and they actually send 100 people. And there's a character in there, I think her name is Anne, who is just in love with the Martian world, like the atmosphere of it, the beauty of it, the untouched nature of it. And what's interesting is that she's basically a conservationist, but like a Mars conservationist. And for her, this like image of like she'd go out in her spacesuit and just like walk for hours out there, and the cold of Mars, the barrenness, the emptiness of it, the rock formation, and the sounds of the wind blowing through the air, all of that stuff was to her like just the pure untouched beauty of Mars. And so it was interesting, as a conservationist on Mars, it's a little different than being a conservationist on Earth. A conservationist on Earth is going to be trying to preserve species from going extinct, whereas a conservationist on Mars is going to be trying to prevent people from introducing new species to Mars. And so the other scientists are like trying to develop fungi that can grow, like extremophiles that can grow on the rocks, because they want to gradually build up the biomass that's on Mars. And she's just like 100% opposed to that. And I always thought that was kind of dumb, but maybe kind of like listening to this footage, listening to this wind, makes me think that, you know, maybe there is something to the idea of just preserving something that is that beautiful, but in an odd way, in a very different way than the beauty of Earth, for instance, which is found in trees and plants and forests.
For the first time, we can hear the wind blowing across the surface of Mars to go along with all of the images that we've acquired of dust devils and dust storms over the many years of exploration on the surface.
This is the sound of the rover driving on Mars. This sound might be a little bit weird because it doesn't sound like a regular driving sound, but that's because the rover's wheels are made of metal. So this metal is rolling over rocks and sand, and it makes this really clanky, squeaky sound.
Next, we have the SuperCam laser zapping rocks. We've taken a lot of pictures of rocks that have been zapped by the SuperCam.
It's kind of
little marks in
disappointing.
the
It just
rocks.
sounds like a clicking
And for the first
sound.
time, we can hear these laser shots.
When it zaps a rock, it actually makes a sound. We can listen to that sound and learn something about the properties of the rock that we're analyzing. This is one of my absolute favorite sounds. This is the sound of a helicopter flying on Mars. We used this sound to actually understand the propagation of sound in general through the Martian atmosphere. And it turns out that we were totally wrong with our models. The Martian atmosphere can propagate sound a lot further than we thought it could.
That is a really cool observation. I think just in general, scientists, if you're doing it right, if you're doing science right, then you get really excited when you get something really wrong. You know, if as long as it's not that you got it wrong because you know, did the math wrong or something like that. But if you had a set of assumptions based, you know, that you thought were pretty good, and then you carried out the assumptions to their logical conclusion, you made a prediction, and then you got the actual data and it turns out you were wrong, that's exciting, because what that means is that some of your assumptions were wrong. And so it's only when you're really wrong about something big that you get the chance to sort of like revise your worldview, revise your set of assumptions, and then get closer to the truth. So I appreciate the fact that when they listened to, you know, they had these recordings and they were able to hear certain wavelengths of the helicopter. They're not like, oh, we were mad because we got it wrong. They're excited because they got it wrong, which means that they got to learn something about how sound propagates through the Martian atmosphere. So that's very cool. So I don't know why it didn't occur to me, but you know, with all the different rovers being released, you know, sent out to Mars and all and other places, it never occurred to me that they would be able to put an audio recording together from Mars. It's really amazing because we get to hear what sounds sound like on another planet. It's just an unimaginable privilege, and I'm so grateful to NASA and to the scientists who put this together for making this happen. So I'm just, thank you, NASA. Thank you, everybody. Like, it's just an amazing thing. There's a short story that I read when I was a kid that really affected me a lot. And this was another science fiction story. And I can't remember the name of it, and I don't know if I'll ever be able to find it again. But it's interesting because it puts you in the emotional state of someone who is the first person to land on Mars. And what's interesting, it's kind of like a tragedy because there's an accident during it, and so you know, it sort of tells it in a non-linear fashion because the narrator of the story is actually injured, and you don't realize that the narrator is like injured until the end of it because he's kind of like reliving scenes from his childhood and he's very disoriented. But he just hears these sounds, and eventually you realize that the sounds that he's hearing are actually are a side effect of the advanced radiation sickness that he has, because he's been, during the process, he picked up a lot of radiation during the crash landing of his spacecraft. But what got me in the story is that at the end of the story, he finally remembers that he's on Mars because he was so disoriented from the crash, and he's happy. He knows he's going to die in about 20 minutes, but for just a brief moment, he's incredibly elated because he realizes that he made it to Mars, and that since he made it to Mars, we made it to Mars. And so I feel, you know, all the more excited about this from hearing these sounds. It just makes me think of the fact that I think in this generation, hopefully, we're going to be able to do that. We're going to be able to send someone to Mars, and because that person or that group of people are going to go to Mars, as we collectively are going to go to Mars in a small way, in like an emotional way. And I really appreciate, again, just like hearing these sounds, because it just brings it to life all the more. So thanks so much for watching. If you enjoyed the video, please go ahead and like and subscribe and hit the notification bell, and I hope you'll join me again soon in the future. Bye.